Whoa, here it is. Back. Here we are. What's up, folks? I'm going to be doing something a little different today. Today I am going to be working on some tooling that I've been spending a lot of time on recently. So, if you're not aware, I've got I've been working on a training program for Cassandra folks to go from running kind of smaller environments or size environments to learn how to take your skills kind of to the next level and to be able to operate, at the scale where you have thousands of nodes or petabytes of data potentially. I've been pretty lucky to be able to work at both Apple and Netflix and kind of see how a lot of the stuff runs at scale, and I've also, have a lot of experience fixing stuff, clusters. So it's kind of interesting for me because I like to be able to spin up lab environments and test things. And as part of the training program, we're actually going to be utilizing this tooling. So the idea is in the class, in my session, which is going to be starting, I think, the first. And I'm joined by Jordan Costello, Cassandra. We're going to be showing people how to actually operate at huge scale. So we've been working on this tool for lab environments, and we're literally going to be spinning up environments for this class, breaking things, changing things. People can get a chance to get hands-on experience the way that I feel is the best way to become a pro. Most of the time, people just have their production environment, not afraid to, make changes. Maybe they have staging environment, but there's always people that are working in that environment. And so what you need is a sandbox, and you need to be able to quickly spin these up. It can't be a pain. So the goal, similar to how MySQL used to work, the goal with MySQL was to be able to spin up an environment in just a few, I think it was 15 minutes, was the end goal with MySQL. And it's one of the reasons why the database was so successful. So I'm just going to go through here and some stuff. All right, so the tool here, I originally had started it several years ago. It was called TLP Cluster. Now it's called ECAS Lab. And you can find it on my website, westernrazorblade.com. So it's over here. Go to tools. You can see all this stuff is here. TLP Stress is, I've rebranded it as ECAS Stress. I developed it while I was there, and so let's dig in. So what I'm going to go through first is kind of a rough overview of what it does. So what you get out of this is an environment. It starts with an AMI. So we have a Packer thing over here. So I'm just going to go ahead and kick off this Packer build. Hopefully, it didn't break it along the way. One of the risks of kind of doing this sort of thing is, if I accidentally broke some stuff, which happens. All right, let's go ahead and. So basically, this starts out, we're going to run a Packer build, and I'm just going to let this thing go. Actually, I will do that. So what this is doing now is this is starting with an Ubuntu AMI. I'll go to the code here and I'll just show you what this looks like. And this is all open source. So this is something that you can take a look at. Um, you can fork if you want to contribute. So what we're doing here is I'm taking these images, an Ubuntu 22 image, and we're installing a whole bunch of stuff, upgrading the image and getting everything up to date, installing the packages that I like. RipGrep is a really nice grep replacement. I need to put exa in here as well. Grabbing this utility YQ. I'll be talking a little bit about what that's used for. Oh wait, I'm not sharing my screen. I messed that up. So I've been talking this whole time without sharing my screen. Lame. Okay. So I was talking before about my tools. That's right here. So if you go to rustyrazorblade.com and then you go to tools, you'll see this here. Okay. So this is, and of course I'm not even showing the right thing. Right over here. Awesome. Now I'm doing it right. Okay. Third time's a charm. Sharing. EasyCast Lab is here. There's this. The GitHub is repo is here. Everything is open source. These are the tools here. So I'll zoom in. Hopefully you can see that a little bit better. So basically what we have here is this process that we're installing systat, unzip, ripgrep, YQ, putting everything in place. Let's just move this over here so it's easier to see. And we'll do that. Where'd it go? There we go. We grab a whole bunch of stuff. We grab a build of EasyCast Stress. So this image contains, so EasyCast Stress is, I think I already just mentioned this, is my, I've rebranded TLP Stress. There's really no reason to continue using the TLP name. TLP doesn't even really exist anymore except for a website. So EasyCast Stress is now the name I'm using to maintain the tool. So if you're using TLP Stress, you're going to want to take a look at EasyCast Stress. We install a whole bunch of packages, multiple versions of Python. I'm going to tell you why in just a moment. I compile FIO from the latest release. The reason why I'm doing that, FIO is a really nice tool for doing disk benchmarking. I'm actually going to be doing some of that next week with EBS. So if you're interested in kind of understanding EBS performance, definitely come and join me for that. I've also got, let's see, some kernel stuff. Async Profiler. I did a stream on the Async Profiler recently. I think that's a pretty interesting tool. This thing right here called Cassandra versions. So this is interesting. So what this is a YAML file that defines the different versions of Cassandra that we want to pull down and have on the image. The cool thing about this project, I think, one cool thing about this project is that the AMI that we're building comes with all 5 of these, and we're actually going to make it so that we can include support for trunk or custom branches. So we're actually going to be able to use this as a dev tool for evaluating the builds of Cassandra. So if you wanted to test out a patch and actually run something, let's suppose it was a test where you wanted to see what would happen if you upgrade from 4.1 to 5.0 and you want to test the new transactional cluster metadata, for example. this will have trunk on it in the long run. So you'll actually be able to test the stuff that is being committed to Cassandra like right now. You'll be able to get a build, the most recent build of Cassandra, and get an up-to-date you can get an up-to-date build and test stuff yourself. So my goal is to make this useful as a dev tool, as a lab tool, really the easiest way to evaluate anything. You'll be able to do your own branches. If you wanted to do, let's say, a test for something, you could do that. We also, so this tool basically specifies for each version, it's got a name and then where it's getting it from, and then the corresponding version of Java and Python that you want to use with it. Now, the reason why this is really cool is there's a utility that this thing is going to come with. Let me just show you what this looks like right here. This utility is use Cassandra. So all of the Cassandra instances are, or the AMI is everything goes inside user local Cassandra. And then there's a version. So it's like user local Cassandra 3.0, 3.11, 4.0, 4.1, 5.0 alpha. And this script will adjust the symlink for one called current. That's what this is. So this will automatically set the symlink up to the whatever version that you specify. So you can just say use Cassandra 4.0, for example, and it handles that. But the other thing that it does is that's really cool, I think, is it sets the Java version for you automatically. So this has all the Java versions that we care about installed. So if you wanted to, let's say, test 4.0, it's going to go ahead and select Java 11 for you, or if you want to override it because we're supporting newer versions of Cassandra, or newer, let's say you wanted to test it with a newer, older version of Java, we're going to have the ability to override that. So you'll be able to select whatever version of Java that you want. And it also selects the right version of Python for you. So you get to, it's a really, really convenient way of operating. And so this build here takes a minute because there's a lot of stuff that gets compiled and built, and it's this whole process. What happened here? Did we die? Oh man, we died. That's okay. So you see, I definitely made the claim before that stuff can break, and I definitely broke it. But it's okay because we already have a build that does work. So I'm gonna go ahead and fire up a cluster right now. So I just pulled, and let me just okay. So that died. Lame. We're going to put this down here, and we're going to take this terminal, make this a little bigger. Oops. And we'll just go bin easy cast lab init. Now, let's just see what happens when we say, well, let's just go ahead and we'll look at the tool first. So there's a handful of commands. Initialize this directory. So I'm working on the Git repo version of this. Like, there will be a version that you don't have to actually go through all this. And we're actually going to publish the AMI as well. So it's going to be really easy to use. You won't even really have to, do that much. But you can do, so this stuff with AMI building, you don't have to do it unless you actually want to have a custom build. So what we say is easy cast lab. I'm just going to fire up one node just because I don't need a whole cluster right now. And the tool is under development. So some of the cluster stuff, my goal is to, in this session, to get is to finish the work to actually spin up a cluster. I don't know if I'm going to be able to do it. I probably will break stuff along the way. But that's part of the fun. So I say easy cast lab init C1, and this just means give me one Cassandra node. So basically what this does is it writes out a whole bunch of files. These aren't even used anymore. These are kind of like a vestigial tail for some stuff that I had before. That's going to go away. But the fun thing here is we are using Terraform. So the project relies very heavily on Packer to create the AMIs. and Terraform to spin up the infrastructure. And remember, this is a lab environment. So Terraform isn't that great if you want to deal with like databases that have a lot of state, especially Cassandra, because it doesn't really know how to like deal with the intricacies of like managing the individual nodes and like not adding too many nodes at once or things like that. So it's good for this, but I probably wouldn't rely on it to run a full environment, although I really haven't thought about it too much. At Netflix and Apple, we kind of had all custom tooling for that. So, okay, so you see this only took like 10 seconds or something. Easy cast lab up. So what this does, the up command will go ahead and this is where it uses this is where it uses Terraform, and it's going to go ahead and spin up. It creates security groups, security group rules, all the things that are necessary to run this. And then it's like, hey, we can actually pick our version now. So we have an instance. So this source.env sh, this is kind of cool because it overrides a bunch of stuff that you're going to want to use frequently, like SSH, SFTP, SCP, and rsync. So if you want to like batch copy files on here, if you want to do any kind of like significant work with these instances, it just kind of saves you a little bit of work. The reason why I say that is because there is a local there's an SSH key. I forgot. It doesn't live here. It lives somewhere else. But it needs to be able to use the right SSH identity. So what we have is an alias. We also in that environment file define a bunch of aliases. So if you do C0, then you get Cassandra instance 0 indexed. C1, C2, etc. It will go ahead and create aliases for you. So you can do fun things like C0 ls, and it will tell you what's in that directory, or you can just do C0 and it brings you in. And you can see that, like, look at this. It's like it still has updates that can be applied immediately. So that's the reason why in the Packer file, it does the update. So the more, if you update, if you build your own AMI with this, it does make it a little bit easier. And the process of building the AMI is going to change a little bit. It's going to be a little bit more self-contained. It'll be easier to use. You just run it through the tool itself. So here, let me just show you the directory structure. So here we actually have, and then local Cassandra. Here we have multiple versions of Cassandra present. And let's see. So let's just exit out of here and EasyCast Lab. We're just going to say okay, 4.1. I meant to hit 4.0, but it's okay. We've got 4.0 there. So what this is doing here, what did I do? Yes, patch config, no such file or directory. Okay, so this is part of the fun here. So I'm going to be fixing this stuff as I'm talking. So clearly, let's just see if I can manually fix this. Probably in patch. So I don't know why this isn't here. Oh, actually, I do know why. Let's go with probably because I didn't do that. So I've been working on a whole bunch of AMIs recently, and sometimes I'll just, so you can specify the AMI using export EasyCastLab AMI, and then this is the AMI that it's going to use. The reason why this is nice is because if you're trying multiple builds, like it won't just use an AMI automatically, and it's not hard coded to use an AMI. You can actually pass whatever AMI you want to it while it runs, and that's it's convenient. So I'm not sure what happened here either. Unable to find Clang libraries. How did that break? What were we building? This is this? Why is this breaking? So this is typically how I work. I try and have two things going on. I have two things going on at the same time. I'm basically constantly context switching between. So this I don't know why this install BCC just all of a sudden broke. We have been making a lot of changes in here. So let me just see what's going on here. Oops. Okay. Do that. All right. Hopefully that you can see that now. So what did I break along the way here? Just gonna go down a little bit here so I can read it a little bit easier. So I don't know why that wouldn't work. Let's see what happens when I rebuild it. So I'll just go ahead and see if it works this time. Maybe it was a one-off. Sometimes there's issues where it'll like run out of disk space or something. But I don't know why I wouldn't have CMake in there. All right, let's see. So we're going to try this again. Init. Hey, what's up, Sarma? How you doing, buddy? Let me know if you have any questions, man. I hope that you find this tool useful. I think that this is going to be pretty cool. All right, so one Cassandra instance, easy cast lab up. Okay, so this is still going. We're doing our build. Okay, we've got our environment. This is going again. You look more smart with this guy. Thanks, man. Yeah, I use these. I use these when I'm coding now. I used to have way better eyesight. Age. Okay, so now easy. Oh wait, let's do something crazy. Let's just see what happened. I was working on this with Jordan West, fellow committer. He's going to be teaching the training with me. We've been working on this tool and making a lot of changes to it, and sometimes it breaks. That's life. So let's just see what happens. I think the last thing I did, I need to run up still. So let's just go. Whoops. Or did I already run up? Oh no, I've got it. So I've got my environment. Let's do use.40. When we call use, so EasyCast Lab, when I call use 40, or when I call up, one of the things that it does is it generates this file, cassandra.patch.yaml. I'm just going to go into this real quick. I'm going to show you what this looks like. Sorry, I guess it's not. It does do it here. So I'm using Kotlin here. What I do is I create this object, and Kotlin's really cool. It lets you create one-off instances of objects, so you don't have to define a class and then create an object from it. It actually creates it's like a single instance class. And these are all Cassandra settings. So cluster name, test cluster, right? I got to actually like fix that. num tokens, seed provider. The reason why I put the seed provider here, the whole reason we have to wait for up is because I need to know what the IP addresses are of the environment. So, here we go, Python. I need to know. Oh, I bet I know why this died. Whatever, deal with that later. I need to know what the IP addresses are of the instances because where is it? Write config. Because what this does is it actually generates the seed list automatically for us. And then it also maps this stuff right here. So it maps the hint directory, data directory, commit log. So one of the things that I was going to work on here today is to actually fix this like data mounting thing because it doesn't. Oh, we can heckle John. Yeah, heckle, do it. The goal here is for it to, and we'll just leave this up front here. The goal of it is to start up the instance. When it starts at the instance, it's going to mount the Cassandra, the data directory. It's going to mount the data directory into mount Cassandra. So even though it's an EBS volume, it's going to use the local instance storage or the EBS attached storage, whichever you have. I am going to include options where if you have multiple drives, you'll have initially it's gonna do something really primitive. It's just gonna dump a shell script out, and you can customize that shell script to whoever you want. So if you want to change something, you can change it. You can do whatever you want because there's a lot of different options that I personally I want to test. So I want to be able to say what happens if we have an EBS volume attached and a local instance volume. Well, in that case, I might want to do something really cool. Where I can, let's go to the blog. Oops, not that. I want to be able to use LVM. In this post I wrote, oh my God, 6 years ago. Oof. I one of the things I really like about LVM is you have the ability to create these like complex setups. So we can set up a volume group where you have one volume that's EBS and one volume that's local. So if you have like a low latency Cassandra requirement, let's suppose you have a low latency Cassandra requirement and you want to be able to do fast node replacements. The idea is that you store everything on EBS, but you use your local drive as a cache. And so you can set it up where it can be a write through cache. So it's like everything will actually be written to EBS, so you get durability. But if you want to change your nodes, you can take the node down, reattach EBS to a new volume, and boot it back up, and then everything will cache locally on your drive. And in my testing, I actually found it's pretty fast. So if you've got like, you could have like a 2 terabyte volume for EBS or a 4 terabyte volume and have pretty dense nodes, and then you can have your local drive. And the reason why that's so good, the reason why I like it is because with EBS, you pay for IOPS. IOPS are, if you it's really easy to accidentally use too many IOPS. And when you do that, you can end up with unpredictable performance. So what this does is it takes the files that are the most used and it puts them on that cache volume. Any good tools to graphically show LVM disk layout? Not that I know of. That's a good question. I'm not really sure. So what I do with LVM, honestly, like I've always been on the command line side of things. So if you have this post, I'll actually just drop this in the chat. So if you take a look here, you can see that like we can actually get pretty decent information about these LVM volumes through here. The LVs command is useful. So if you were to do like sudo LVs, oops, no, not on here, zero. See, I don't have any on here. I don't have any of this set up on here. Oops, wrong one. So I just have this. I should actually mount this right now. Yeah, and this keeps dying. Why? Why do you die? Do that later. Is there another chat or Discord channel accompanying this? Okay, Thomas, I see you're on LinkedIn. So I'm streaming simultaneously to both YouTube and to LinkedIn. So people don't get to see each other's messages. Yeah, I should probably be saying what people are saying to me, or just I actually have I set up a Slack workspace. I should actually set up tell you what, I'm going to set up a Slack channel for my streams so people can ask questions in there. And maybe I can figure out a way to get all the questions from YouTube and LinkedIn to go in the same spot. I hadn't thought about that. Thanks for bringing that up, Thomas. So where was I? Okay, so I've got this thing, right? And let's just go ahead and do this. Make file system. Oops. Okay, then we're going to go ahead and we're going to mount this. So this will be automated soon, hopefully today. Boom. Okay, so in the future, there you are, Thomas. All right, cool. Yeah, you're on both now. Nice. Pumping up my streaming numbers. All right, so what did I do last year? So too much yapping on my part. Okay, so now I need to use, right? And this is one of the reasons why I put this here. To be honest, I sometimes forget what I'm doing. So easy cast lab use version. So let's just go ahead and use 4.0 like we talked about. So I was talking a little bit about that YAML configuration thing. So what this does is oh no, cannot assign key in this way. Let's just go on there and do it manually. Let's see what happens. Oops, just use 0. Was it patch Cassandra or something like that? Patch YAML, I forgot what I called it. Patch config. Okay. All right, so this go ahead. So what this does is it takes this YAML file. This was actually uploaded as part of the use Cassandra. So when you call use Cassandra 3.0, what it does is it uploads this patch. And so with this patch is actually pretty simple. It sets up the data directories, it sets up the seeds, sets up all the stuff that you care about. And you can actually go in and you can add any YAML that's valid for Cassandra that you want in here. And what it's supposed to do is it takes, so if we look at user local Cassandra, so if we look in here, you can see that this is pointing to here. So when I call patch config, and then I call cassandra.patch.yaml, what this is supposed to do, oh, I know what I did. I know what's going on. I know what's happening. All right, let's just go ahead and manually fix this because I know exactly what the problem is. So this right here, this was actually supposed to be that. It's fixed. It's fixed in the repo, but because the Packer build isn't working, let's see. And then, so this right here, okay, user local, let's just go and we'll just go in and fix this manually. Local Cassandra. So we see current. Let's go into comp. Oops, not triggers. We're not using those. Well, you could. You could. Okay, so of course. So this was looking for, it's because I screwed up the name. Let's just go ahead and do this. Again, this is fixed in the latest Packer build, but because I broke that, so many of my things, this is what happens. This is what happens when you try and do things at the last minute and then run it without testing it, like just with such confidence, just like bearing my soul to the world and nothing works. Whatever, it's fun. Patch config. Patch not provided in env. Oh, right. Let's go back. I know exactly what that is. Again, it's funny because this is all here. See this? This is literally what it needs to be doing. So I'm just going to go ahead and make it do this. I'm done fixing stuff. Here we go. This should work. Bam. Okay. So as part of the build process, what it will do, or what it would do if my Packer was working right, is it backs up the original Cassandra into Cassandra orig.yaml. And the reason why I do that is because what I take, and I'll show you the code, this YQ command, what this does is it takes the original YAML and then applies the patch from here. This merges the YAML together. This overrides anything in the original YAML with this. Now, the reason why I don't take the current YAML and do that is because if you wanted to like unset something, you wouldn't have a way of doing it. So the YAML is nice because you can look at the patch and you can see exactly what changes that you use. So if you were to share this with somebody, you wouldn't run the likelihood, or you wouldn't run the possibility of having stuff in your YAML and having removed it and then like accidentally, it just not working. So this now is patched. So if we look here, Cassandra current comp Cassandra.yaml, you can see now that num tokens is set to 4. So this defaults to 16. I strongly feel that people should either be using 4 or 1. I prioritize 4, although at a lot of places like like a Netflix, for example, or Apple, everyone uses, at least when I was there, we used 1, and that's partially due to legacy reasons. It's easy to double the size of a cluster, and you don't run the risk of availability. See, the more tokens you have, the higher the risk of unavailability. There was a really, really good post that I'm not going to look for right now. I don't know if someone can look it up or knows it in the chat, but there's a increased likelihood that 2 nodes are going to own the same token range, right? So even if they're in different racks, if you have if you're using 16 nodes or 16 V nodes, then there's 16 opportunities for a node. If you're using RF3, it's going to be peers with 4 other nodes. So it's 4 times 16. So you, at most, each node can be a peer with the 2 nodes with token, like for a given token, there's the 2 nodes previous of it and the 2 nodes after it. So, it kind of is not great to use 16 because any 2 nodes going down in 2 different racks or 2 different availability zones will break quorum for some of your data. So I don't like that. So basically the problem increases massively as you go up. So with 4, it's not so bad because you've got it's 4 times RF minus 1 times 2. So your peer was 16 nodes. So if you have like a 96 node cluster or something, it's not so bad. The odds of downtime or significantly less, but generally speaking, you don't want to use a lot of tokens. So 4 is my opinion, the right number, or 1 if you really want to maximize availability. So this, let's see. So you can see here, this stuff got popped in at the end because it wasn't present in the original YAML. So enable drop. After the end, it'll say hints directory, mount Cassandra hints, data file directory, mount Cassandra data. So one of the things that this needs to do is make sure that a mount Cassandra is owned by Cassandra. And we also have a command here called start. So what's pretty cool here is that built in, I'm using a library called Apache Mina. I don't know if you're not familiar with it. The documentation on it is a little rough in places, but as all of my projects have rough documentation, so I think that's just par for the course. But it uses Apache Mina to move files around and to SSH in. So what's really cool about this is when you call like up, for instance. So I am only running this with one node right here because it's a demo and I'm cheap and I don't want to pay for multiple instances. But it will actually upload the configuration files to all the instances. And when you call start, it SSHs into all the instances and runs the start command. So when I run C0, let's see if this is up. Oops. Okay. Cool. Let's see if this works. Oh, it's still starting up. Or it's up. And no. What have I done? No nodes present in the cluster. Okay, so we do have a system log. So let's just see what happens here. Startup complete. Okay. Well, don't know what I did there. Oh, still going. We do it. Oh, come on. Okay. So this says 172, 31308, 202, 202. Okay. Oh, I know why. I need to set the host name. Okay. That on my to-do list. Okay. Test cluster. Cool. Up and running. All right. So there's definitely a little bit left to do here. There's I need to figure out what's going on the Packer side of things. Probably a good idea to do that sooner rather than later. Let's just see what else is on my list here. Let's see. This might run. So there's a there is, yeah, see, this isn't set. So there needs to be an environment variable set here. Easy cast stress. I may have mentioned this a couple times already, but this is a rebranding of TLP stress. TLP stress is the tool that I wrote when I was at the last pickle. It's a very, very popular tool for doing benchmarking with Cassandra. The goal is to have it be easy to use. And I think I've succeeded in that. I've used it to benchmark a ton of stuff, and it's used in some of the biggest clusters in the world. So let's just run. So if I do this, it's probably just going to fail. It's going to be like, no way, we can't connect. Yeah, see, that's taking forever. But when I run it, oops, easy cast. Okay, so there's supposed to be environment variable set and host. So host should actually, why isn't that documented? Let's just bring this up. When I go run here, thanks. Host, easy cast stress Cassandra host. Okay, cool. So if I do this, and then I put in my IP address, let's just make sure that I set this up right. So LSBL queuing. Okay, so this is here. So we've got the drive locally. Oh yeah, this is also a pretty small box. But that's mounted. Cassandra. Okay, cool. So the all the data directories are set up correctly. Let's see. So if I now do easy cast stress run evalu. Again, this is and here's the thing. This is actually I'm doing a very, very like abbreviated version of this. This can actually also spin up instances that you can use to run the stress tool, and you should. If you're running a test, if you're running the stress test on the same node that you're running Cassandra, you're not introducing network overhead. So you're getting rid of the network overhead, but you're also introducing kind of a noisy neighbor problem. So you don't want, and easy cast stress, you can run it with a lot of threads. So this can actually take up like a ton of resources. And this is set up right now where it's going to do, in the beginning, it kind of throws a ton of queries at it. I'm going to make a modification so that it ramps them up. And then these latency numbers are actually kind of crazy. Like this is super bad, and we're getting a ton of errors over here. So let's just go ahead and decrease. Let's just go ahead and set this to 100. I haven't actually been running any of the performance stuff in this environment yet, and this is, like I said, there's like not a lot available on here, and also, oops, because this is such I haven't done any of the JVM stuff yet, JVM changes. So this is using whatever settings come by default with Cassandra, and it's not how I run production. It's good for a laptop, which is how everybody tests Cassandra, but you really don't want to put the Cassandra JVM settings as is in production. To be honest, I don't. You leave a lot on the table when you do that. So there's a lot of reasons to use other stuff. This is also using CMS. Because I'm using 4. I'm using Cassandra 4. I forgot that I'm doing that. Yeah, these settings are actually terrible. These are awful. These are changed in Cassandra 4.1. But this is like this is so horrible. We There's a lot of hesitation in the project to change this for a long time, and then you can see here, this is only using 3.8 gigs of RAM, so not a lot of space for mem tables. Not great. So let's just rerun this. Okay, so gotta fix that. A lot of little things to fix. Oh, and I know why that's wrong. The reason why that's not set up correctly is because it has to do with the way that I think it's in here. Okay, so in here I'm actually explicitly calling out the Cassandra log directory. So when I call it as this user, it doesn't actually know that. So I need to export. This. Let's just go ahead and set this manually. Let's fix this. So, and hey, this is how it goes. I'm gonna, oops, wrong project. Help if I was in the right project. And this is. So, let's see. So this is going to be for the regular user. Let's just put it. Let's see. Yeah, let's just do this. There's not that there's really not a lot of logs. Where do I put this? Just profile D or something like that. All right. For now, when I run this, cool. 2015 called and they wanted their heat management right. You got it, man. Dude, you could not be more right. So I'm just gonna talk for a minute about this because it drives me crazy. The settings. I'm gonna bring them up again. I'll tell you why they're terrible, why you should not use them, and why they're holding you back. No matter what you're doing, there is no way that these settings are good for you, no matter what the workload is. It really doesn't matter. I actually wrote a blog post on this topic. Let's go with workloads. And this was actually a really fun post for me to write. I'll share it in here. The deal is, and if you can read this, at your own leisure. You don't have to take notes. But the thing that we get with the default settings, a couple things. One, it's not a very big heap. It's capped at 8 gigs. Lame. The reason why that's bad is because Cassandra has not historically been too great at being efficient with allocations. We actually do a lot of allocations. We're not good at reusing buffers. We do a lot of unnecessary copying. So we actually have like allocation amplification, especially on reads. The read path is particularly wasteful. So when you allocate a ton, you need to have a big heap. Otherwise, you're going to have like really frequent GC pauses. And that's probably what we have going on here. I'm sure that with like very little load on this thing, we probably had GC pauses like crazy already. The other problem, and this is something that is really frustrating. The other problem is this. So XMN, this is the size of your new gen. 200 megs is what this thing is using right now. That is terrible. So your new gen is where everything is allocated. So if you're using older versions of Cassandra, you might be using this, in which case you're leaving a lot, you're actually wasting a lot of money. I always talk about performance, but the thing is that performance and cost are directly tied together. You might be running a 60 node cluster when you could actually run 20. And a lot of what I do is actually helping people save money. So you've got this space. This is in the new gen. And all your allocations go in the new gen, almost all. There's these things called humongous objects. Those can go elsewhere. And if something's too big, it gets allocated directly in the old gen, basically. But this little space, this 200 megs, gets filled up, and then you had a GC pause, and everything stops, and everything gets copied over into the survivor space. Now, the survivor space is determined by survivor ratio. So it's a 1 to 8, or 8 to 1, however you want to think about it. There is a Eden space, and then there's a survivor space. The survivor space is going to be 1/8 the size of the Eden space. Any objects that are still live get copied over into the survivor. Anything that, if there's not enough room in survivor, it gets copied over into the old gen. But I skipped a step there. When the pause happens, you have this thing called max tenuring threshold. So you actually have 2 survivor regions. Only one of them is active at a given time. During the pause, the first thing that happens is it takes all the stuff that's in one survivor space and copies it to the other one. So it's basically going back and forth. The idea here is that if we can bounce objects around a little bit, maybe they age out, and they, like, if they're short-lived, copying them around a couple times is actually not like the worst thing in the world. But when we have max tenuring threshold and a really tiny new gen, what ends up happening is we have these short-lived objects. Maybe they only live for a second, but if you allocate enough so that you're constantly hitting GC pauses, what happens is that these objects get unnecessarily copied back and forth. And the max tenuring threshold is the point at which they get copied into the old gen. So you can actually have these like short-lived objects that should only be around for a couple seconds get copied into the old gen. And then once they're in the old gen, now what happens is that now you've prematurely put that stuff in. Now you fill up the old gen. And the old gen gets filled up. Hey, what do you know? Now we have a problem. And we have to do a full GC, and full GCs take forever. So if you've ever run a Cassandra cluster and you've noticed like a 20-second GC pause, it's probably full GC. And if you're running these default settings, which is pre-4.1, you're almost guaranteed to hit this problem with par new and CMS if you put any amount of load on the cluster. And what most people do is they just fire up more nodes. And this is so wasteful. So if you're doing this right now, you definitely want to increase the size of your heap. So I'm very comfortable running the 16, 20, even 31 gig heap. 31 is where you want to stop. And you actually want to use a pretty big new gen. And you want to increase the max tenuring threshold. So by doing this, what it does is it gives you a lot of room to work with. And it prevents objects from being copied into the old gen. Even stuff in your mem tables with a big enough space and a reasonably sized mem table heap space, you can prevent almost all of your objects from going into the old gen, which means you'll literally never see a full GC. And the frequency of your GC pauses are going to be significantly less because you have a huge new gen, so it takes way longer to fill up. So I have 200 megs here, but if I was running this in a production environment and I wanted to use PAR new CMS, which I've done hundreds of clusters, I would be giving this a 31 gig heap and like a 20 gig new gen, or sorry, yeah, a 20 gig new gen. And I would bump up my max tenuring threshold to like 4, and I would decrease the survivor ratio to 4. And what that does is it gives more room for the survivor space. It gives a lot of room for Eden space, and it lets things bounce around a few times. So it's actually cheaper to do this than it is to let everything get prematurely promoted into the old gen and give you full GC pauses. So little GC tip. I can't help but ramble about that type of thing. I get so fired up when I see these settings, and everybody's using them. Everybody's using them. So if you're using them, give me a call. I can help you. What else? Let's run this. Oops. Okay, so this is terrible. So what we're gonna do here is we're gonna start low. So we're gonna start with 100. Now, my original work on TLP stress was you used to have to set a C flag. I mean, you didn't have to; it defaulted to like 50. But C was for concurrency. So there was a number of in-flight queries that it could have at any given time. And if you wanted to, like, there was no real way of saying, like, let's do a, give me 1,000 queries or 100,000 queries a second. So in my fork, it now has a real scheduler. It will schedule some number, like whatever number. So it'll schedule 100 queries a second in this case. But that leads us to another problem. There's a lot of folks, and we'll do 50% reads. There are a lot, like me included, most people actually want to be able to say, hey, like, I have a latency requirement. Figure out what the throughput is that can still meet my latency requirement. So what I'm going to do here is I'm going to pass max RLAT. So this is our max read latency. And I'm going to pass max WLAT. This is my write latency. And I'm also going to pass dash D1H. This just runs it for 1 hour. So we're going to go ahead and do this. And now what you can see here, it says enabling latency optimizer starting at 100. Okay. So this is pretty cool. Let's go here. I'm just going to show you in a separate screen how this works. So this is just going to run over here. So you can see this is doing 50% reads. So there's a log. Of course, there's a log. All right. So this is the fun thing about this. The rate limiter periodically looks at your current latencies, and it will make adjustments to try and get you as close as it can to the latency numbers that you specified. So you can see here, this is saying, hey, like, let's be honest, this is terrible. Although, I mean, this is actually not that bad too. So these numbers, for some reason, this spikes up in the beginning. I got to figure out what's going on here. The first like 10 seconds, it like the numbers are terrible, and then it picks up, and then it drops down. So here, our latency, our write latency is 2, and that's actually what I specified up here. So this isn't that crazy. So max WLAT 2, max readlat 10. So I asked it to keep things under 2 milliseconds, and that's what it's doing. It's got it right here. So this is a really useful tool. If you want to figure out what your cluster is capable of throughput wise, this is a whatever kind of tiny, small instance, unoptimized, garbage settings. It figures it out. So I know on this garbage box, I can do like nothing. Um, Updating rate limiter. You can see here, it's like constantly making these like adjustments. And here, like adjustment factor 1.01. It's just a 1% increase, right? Because we're so close. We'd butt it up right against that, up against these numbers. You know, it's going to go ahead and keep making adjustments. So this is going to increase it. So you can see the current rate limiter is at 2, and it's not increasing it by a lot. Like it's just 28, 29, and every 5 seconds it makes like micro adjustments to it. And it's also so close that like, the numbers aren't going to be great. So one thing to keep in mind is that you do have to run this for a little while. And what happened before was, see this right here, it was like too high. The current latency over max for latency, reducing by 10%. So it went down, 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 down. Now it's too low. Now it's slowly adjusting it. So if you have like really poor performing boxes, these adjustments might take a little while because it's actually very close. Like I know as a like percentage, it's off by a lot, but we're within 1.4 milliseconds of the target time. So there's like a curve that it uses to make these adjustments. It doesn't just look at it and say like we can actually like a write latency, we're at a third of what it is. So like let's triple it. That doesn't work. That doesn't work at all. So at the most, I think I have it set up where it like kind of tops out at like a 5% adjustment, but it is also making these adjustments every few seconds. So the other thing is that the JVM also has time to warm up. So there's kind of a lot going on. You need to run this for a little while. And you can see here, like, these numbers were too high and then it gets over here. And then now it's sort of like these numbers are like trickling, dancing around. It's coming up a little bit. And then this, like, it's set to 39 right now, 50% reads. So we should be seeing 20 and 20. That's pretty close. All right, enough of that. I'm gonna, if anyone has any questions, please feel free to drop them in the chat. I will repeat your question for the sake of everybody on the different networks. But I'm now gonna go and try and fix some of these issues that I found. You can see I'm already like working on this here. I'm gonna keep this up, but I am going to drop this guy out. And I'm going to see if I can fix what's going on here in this Packer build, because this is kind of like the most important thing I have. So let's just, let's see. What was it doing before? I forgot why it broke. Let's go with, so this is also, I don't know if you noticed, but when I ran this command originally, I piped it to T and then output because I didn't want to have to look at my terminal. So here it says CMake error. Wait a sec. What is this? What is going on here? Not a Git repository. Okay. That's definitely the problem. What was it actually trying to run? Build Essential is in the newest version. Git is at the newest version. This ran. Python is Python 3. How did I break this? I'm not seeing what it's trying to build. I mean, this is maybe it's. I wonder if it's in any of the new stuff that we. I feel like it probably is in the new stuff that we just added. Um, let's see. Oh, it broke in BCC. Why would that happen? That was working. So let's take a look. So I do a let's see. Okay, so this happens after Cassandra. Install BCC. Let's just make this a little bit bigger. I wonder if this has to do with the fact that we've got. I wonder if it's because it's after Python. You know what? Oh, so it installs Python. I'm willing to bet that because I'm saying, I bet if I bet it's this. Let's just try that. Okay, so I think what's happening here is that it installs. It's either because it's either a Python 3 issue because it BCC tools has this line right here. So I wonder if you know what we can actually we can try it on this box. We don't have to. So I wonder if. All right, so if we're using Python, so there's the two things that it could be here. It could either be because it's in the test in this that it was looking for Python 3, or it could be because it's this PyEnv thing that we have here. So we need it to be able to support multiple versions of Python, which is why this is here. Let's just see what happens. Oops. Let's just see what happens when we do this. I don't know. Maybe it works. Oh no. How would it be doing it here? Let's run it the same way it does it here. No, I don't know what it does. Let's see. Does it just not tell me? Oh no. Oh, search. Yeah, I don't know what it actually does when it runs that. So let's just see what it does. And I'll tell you what, here's what I'm going to do now. While that's going, I'm also going to add this. So this debug command, this is kind of cool. Packer lets you run this debug command, and it kind of asks an annoying amount of information, but it's like pretty useful. So we've got this like EC2 Ubuntu guy right there. Security group. It's going to go ahead. It launches the instance. So if this thing breaks, it's going to leave the instance up. Then I'm going to SSH into it. I'm going to figure out what's going on. So that it should be really easy to figure out what's happening once I've done that. So we've got the IP, we've got that. Set up a new one. Whoops. So that's just going up there. Oops. Okay, SSH running, public IP, cool. Sure, go ahead. Denied. Oh. There we go. All right. Okay, YQ, done. I don't know why I have these on. I don't even need them. I'm wearing headphones unnecessarily. That's annoying. All right, any questions while I take a break here? All this stuff builds and I just wait for failure. I wait for. Normally failure would be disappointing, but maybe this time would be nice. I think there's two things that could be going on. Like I said, I think that it's either because there's something about the Python version that's installed, in which case maybe I need to install Python 1.12 or 3.12. So maybe that's it. Or it could have to do with the order that it was installed. So when some of these things, when you install like one version after the other, the second one becomes active. I don't really know. So this is doing PyEnv right now. And feel free to throw out any questions on other topics, like if you're curious about like, what the tool can and can't do, or even just general questions. I mean, if I have a moment and I've got a little bit of downtime right now, I'm happy to answer stuff. Especially if it's about the training program, because I'd love to talk about that, but we don't have to talk about that if you don't. There's no questions. That's going. This is going. Okay. Clearly, this takes a second. So, one interesting thing about this is that this is actually all being done on an EBS GP2 volume. Might make this a GP3 and see if it builds faster. Yeah, might do that. Not now though. First, I have to fix this. I can't introduce more bugs while trying to fix my first bugs. Let's also just take a quick look here at PyM and see what's going on. Let's do this. Let's just move this out of here. Okay, see what versions we've got. Okay, because then there's the chance where it's like, what is BTD tools? Maybe it requires version. Hmm. Okay, if you were changing, so you were changing the new gen Java settings, but you were continuing the CMS. I've always moved to G1 from the defaults. I haven't had a chance to put ZGC through its paces yet, but it's on my list. Yeah, Thomas, 100%. We moved. I have been moving people to G1 for a while now. I guess what I was trying to say was, if you were to keep using, if you were determined to use Parnu and CMS, there's a right way to use it, and there's a wrong way to use it. I would call the defaults out of in the Cassandra YAML, or sorry, in the Cassandra, the ones that are calculated for you automatically in Cassandra m.sh. I would consider those objectively wrong, because they will literally cost you, like, it will make your cluster like between like 2 and 5 times more expensive to run. It actually drives me kind of crazy, because Cassandra gets a reputation as being difficult to run. I mean, and there's a lot of difficult topics in it. There's a lot of difficult concepts, but it also gets a reputation of being slow. And it really bothers me, because I have so many cases where I have improved Cassandra latency and throughput by a factor of 10 by doing a little bit of tuning. And yeah, it's so frustrating, because it's like, it's not just about improving performance, it's about cost. If you say that I need to achieve X latency, and the only way to do it is to add nodes, then you end up running like, and you'll find like old advice on the internet about like, oh, run Cassandra with like 200 gigs per node. It's fundamentally wrong. It's just fundamentally wrong. And what really bugs me is that there have been folks that have migrated away, gone through the entire process of migrating away from Cassandra to Scylla, and I have no issue with Scylla. I think Scylla is actually a great thing for Cassandra, because it makes us it definitely makes the project want to be better. We have to compete with it. And the people that are over there are super smart. Like, they're a really, really smart group of people. But there is something disingenuous about like a blog post that's like, we moved away from Cassandra because of performance reasons. Like, to do all the effort of moving away, when you could make like 5 tweaks and it's 10 times better. That is it drives me nuts because it's like not only did the people that moved away from Cassandra do so for like they basically did like a Rube Goldberg machine of moving away from Cassandra because of performance when they used the defaults. It's like they you make what I say is the wrong decision. You should probably try to understand your system first and tune it and get it to as good as it can be. Because if you would change 5 defaults, that's like not a lot of work, right? Like going ahead and changing GC settings is so easy. And then to go and put up a post about it, it's like, you know, yeah. The criticism posts where people have a like ignorance of the a few basic tuning things that I've literally written everywhere. Yeah, I it just bugs me. So, ENS. You're gonna have to give me a refresher on that. What are we talking about? ENS. I'm just gonna say, what's this ENS comment? I don't really remember offhand what this is referring to. Here's a good one. On a few occasions, I've had the opportunity. I just realized I can show the comments on the screen. I should have been doing this whole time. On a few occasions, I've had the opportunity to run clusters with Azul Zulu. Yeah, I'm interested to hear more about this. There's some really smart stuff in there. One of the things that I'm excited about is that in Cassandra 5, we are supporting newer versions of Java. 17, I think, is what we're saying that we can go up to. Oh, hold on. Okay, cool. We're at install Cassandra. Go ahead, go. It's time. Finally at the perfect part. ZGC and Shenandoah are using very similar algorithms to what you see in Azul. The ability to do more concurrent operations during collections while the JVM is running is going to be a thing that well, it's there. I'm not saying it's not. It's going to be a thing. Okay, here we are. Look at that. All right, let's figure out what went wrong here. I'm on this node, BCC. Install BCC. Okay, so here we have it. It says d Python command equals Python 3. So if I run Python 3, meaning 3.10. So, and then it says unable to find Clang libraries. But I think that that's actually a result of something that happens up here. I think that this is actually, I think it's actually a result of this. So let's just walk through this and see what this does. Ignore that. Okay, you got it. No problem. No, I'm done. All right, let's go through line by line. Um, so we're in here. Let's just see what happens when we run. Do I have the builder? Yes. Okay, so we got here. What's this do? Oh, okay. What? Okay. Let's just see what happens when we do this. Okay, so unable to find Clang libraries. And yet Clang is installed. I wonder if it has to do with that, or if it has to do with PyM. So let's just see what happens if I get rid of the PyM thing, because I don't know. I got a feeling about it. I got a feeling it's this PyM business. And let's just go. Let's see now. There's a thing in here about building this. Let's see what this says. Okay, let's just see what happens there. Maybe there's something with there's something there. So maybe this will work. Nope. Okay, still does not like this. Oh, could not. Why is this not in here? All right, let's just see if this is related. Let's just see if this is related to PyM and get rid of it. Let's see. Definitely ready to solicit advice. um, I don't know. I just have such a weird feeling about the. Maybe this thing wasn't. CMake minimum required. Okay. Also, so here's the weird thing about this. This was working. This has been working. So there must have been something. There must have been a dependency installed for it that broke it. I don't see what I would have added. Hmm. Okay, so this isn't. I don't think it's actually the PyM thing. because it's not touching it at all. I think I was wrong about that. So let's do this. Run again. I want to get that error. We'll just bring this back to the way it was. I don't remember what the error was, and I don't feel like looking. Okay, let's go with this. Oops. Let's see if I'm missing some stuff. Hmm. I don't know. This is weird. Oh. Hmm. So the reason why I've been building it is because I found that if I install it in package, one, I'm getting an older version, but two, it doesn't actually run correctly. I end up getting a lot of errors with it. So hmm, okay, maybe this has changed since I. Whoa! What is all this? Why is this stuff not here? we remove stuff? What is this? That's weird, right? Just you think that I would have installed everything here, but apparently not. Maybe I'm getting old. Let's see. Turns out I just like can't follow instructions. Hmm. I don't know why I'm doing that. Okay, so clearly the issue is just I don't know. I don't know. Oh, okay. So here's the Debian list, and then I'm using Jammy. Um, yeah, dude, right? 100% right, Thomas. No idea what I'm doing. Clearly, it's weird because this I'm I'm following the instructions. Like these are the Ubuntu instructions. Ubuntu, and yet this started working when I followed the Debian. So I think what I'm going to do is, I mean, what is going on here? We don't need that. And let's just get rid of that. Okay, Ubuntu clone. We're not going to build. We're not going to do that. I'm not that crazy. So CD. So this is. Let's just comment all this stuff out. Lots of comments. Go away. I love my AI that just like gives me crappy advice. Um, okay, so I've done this. And let's see. So now we are in the build directory. Keep that. Keep that. Is that go away? Is that what I did here? No. I simply did. I want Lewis support. I don't know. No. All right, I'm just going to kill this. I don't need that anymore. Whoops. Oh, no. Hope I didn't just kill it. Oh, whatever. I am going to kill it. I don't even care. We are going rogue. We're just going to see what happens. Here we are. All of the stuff. I don't know why. This is this the same list? Bison? See, zip isn't zip there? There's like a bunch of stuff missing. At least the canonical folks have some active community engagement and a great Slack server. I didn't know. Can you share that? I would actually love to join that Slack. Thomas, please drop a link in. All right. Yeah, because I actually would love to get them to fix the BCC tools package. Because if they can do that, then for the Amazon AMI, then I can skip all this. I would love to skip this. This is the most time-consuming part of the build. Boom. We're going to run it again. And you know what? I'm not waiting around. Build. All right, fun time. Shake my drink up. Hey, what version of Cassandra are you running? Drop it in the comment, please. I'd love to hear from folks that are running 4.1 or 4.0, or have gone through the upgrade process. If you've noticed a difference on the performance side of things. I'm thinking about doing some performance evaluations, kind of looking at the total cost of ownership between 3.0 and 4.0. I'm really curious to see, for the same workload, what the difference is going to be performance-wise. I think that'll be a really interesting, really interesting thing to take a look at. Because again, it's to me, it's all about reducing the cost. I think if you can run, large deployments with Amazon, you'll spend millions on an environment. And if you're not careful, you just throw Cassandra out of the box. You might spend 3 or 4 times what you need to, and if you're talking hundreds or thousands of nodes, that can be millions of dollars a year. All right, so we're at the IM bit. Shall I entertain you with my singing? It's quite bad. We are compiling. Yeah. All right, we're on the cusp. I'm also curious if there's a new build available. All right, let's see. What do we got here? It was attached as an ingredient DB to a product. We're still at 311. Most of the clusters were under 50 nodes. What's the product? Do you mind sharing the product? Curious to know about it. Or if you'd want to discuss it. Love to have you talk about it, share what you're doing. This is community stream, people. Community stream. you're in the community and you want to talk about what you're doing, I'd love to have you on. Installing Python 3.10. I'm on the proverbial edge of my seat. I really need to figure out what's going on here. Let's see what the, I'm like, where is the Ubuntu slap? No. Where is it? Oh, there we go. Product was 6. It was a DB for real-time analytics ingest for 5G core, LTE core, and LTE RAN networks. Oh, interesting. I've done a little bit of work with some telcos. Two major telcos. Served as a storage for Datomic, which is a closure-based graph database. Interesting. That's cool. All right. No, still doing it. All right. Let's see here. Do I still have a cluster up? How loud is my mechanical keyboard? Is it just obnoxious? I will never change. It's not. I'm not asking because I'm because I'm going to do anything differently. What was this? Is it still up? Oh, it is. Okay. Oh, I know what I could do. I have a. Whoa. Oh, there it goes. Cassandra. Wait a sec. If this is. What is this doing? Actually, Cassandra. Hello? Where are we? Okay, we are now installing the various versions of Cassandra. And here we've got that scary thing, but I think it's building. So I don't know what was going on before. I don't know if it was maybe something changed. Maybe this is a different maybe a package was upgraded or something, and now it broke the build. Should probably check into that, but I won't. Like, I should probably check into it. I don't care. I'm never ever going to check into that. But I will check to see if there's a new version of BCC, because if there is, so this is 291. What do I got? Oh! What's going on here? You know what? If this works, I'm gonna commit this, because I want to, be nice if it worked. But if this actually builds, what I'm going to do is I'm going to do one last test. I said I was planning on doing this till 1, but I'm really curious. So what I'm going to do is get the Packer thing fixed. While this is going here, maybe I can do this. So yes, and there we go. So what I'll do is this is gonna go. Ugh. This is actually not a. This should be here. Let's go with. Let's put that here. Okay, so this is gonna. And then we'll go with. So we will do context dot upload. Oh no, I think we actually have a like a nice helper now. Jordan just did this. Where is it? I think it's called like with hosts or something. Did I not pull? I wonder if I just am like. No. This was at 10 o'clock last night. Oh, cool. Okay. I'm actually not sure what this does. Let's see. What do we do here? Oh, that's nice. I like that. That is nice. That's actually really elegant. I was doing it kind of like annoyingly before. So we'll just say context SSH upload IT. Oh, this has to be something else. This has to be a path. Probably just make a shortcut so it'll automatically do a path, but okay. Does it execute remotely? Cool. Boom. All right, so that might actually, assuming that 5 seconds, I probably am gonna have to like so I don't know, I don't actually remember what happens if this doesn't work. So I might actually deliberately make this error out just to see what exception or whatever comes out of this. But the good news, and I'm all about the good news, is that it seems that we are past the issue that was blocking it. Again, I have no idea why. I should probably move this to a separate thing. This whole thing. All right, what do I need now? So I've got this. I wanted to add something else. I wanted to add something else. Oh, the disk stuff. I think what I'm going to do there is just I'm just going to like copy that in. I'm just going to put it as a separate text file as like a resource. I'm going to set it up as a resource instead because that's actually pretty convenient. What's in here? Oh yeah, this is fun. I don't think I need any of this anymore. Get rid of that soon. All right. Nice. Okay, it worked. All right. I'm going to start this thing up and I'm going to go through this process one more time. I think I'm going to put it on a bigger instance because this is a tiny instance right now. But the disk stuff, that's what I want to do. Should I just get it done real quick? Just put it here, whatever. Move it later. Canonical Stack was for their OpenStack product. I thought it for sure had a bunch of support. Yeah. That's a bummer. I don't. I should really just report this issue to them. Anyway. So. Cool. Thanks. Thanks, man. Yes. Waiting for the AMI to become ready. We're here. We're almost here. Feels nice to have fixed that. So it's been a while since I've had to copy resources. Let's see. Let's do XFS. I don't even remember what it was. So I'm just going to launch. I'm going to launch this. And I'm going to do the disk stuff afterwards. I was really hoping to get it done today, but it's okay. It's fine. It's fine. Yeah. So basically, let's just see if it builds. Okay. So this might work. This might work. was my favorite part, just sitting here waiting for it. So the other option that I have is to build my own deb, which I'm really tempted to, or take a look at using the upstream where is it? Now, I thought I did this before, and thought it failed, but probably be worth looking at again. Maybe they fixed it. It'd be nice not to, because this would cut down like several minutes off the Packer build. Right now, the Packer build takes like 10 minutes, and it's only going to get worse because there's going to be like, I'll just show you real quick while this is going on. So here, what I want to do, let's just say that we say trunk, right? And then what I'd love to do is something that's like this. Something like this. And then we'd probably also do like, I'm going to put Java, Python version. This could be cool. So essentially, what this would need would be in the build Cassandra, wherever that went. Install Cassandra. So in here, what this would need to do would be to, as it's like, one, it grabs all the Cassandra versions, right? So this is, this would probably need to be, I probably need to specify here in URL. I don't really know a lot about YQ. I just started using it a few days ago, but I think the way that I would do this, I'm just going to put this here. Any URL that ends in tar.gz gets this treatment. This right here. And then anything that ends in .git goes to the Git repo. And it's probably going to I'm probably going to want to specify this because what I really like to do is like that. So I want to build the head of a branch. No. Yeah, so it's lowercase. So just go away. Everything, all of you, just all the files. Okay. something like what is it not? Do I not? Oh, because 5.1 is trunk. Okay, that's okay. Let's for the sake of argument. So we have an alpha. So we have a. Oh, this is beta. I need to update this. No, this is good. This is good. So I probably want to do this. Okay. So 5.0, you can run the beta, or you can run trunk, or you can run the tip of the 5.0 branch. I think that this would be really cool. Or, you know, if you were to go to here, let's suppose I had a custom patch. Right, whatever it's called. And so this would be nice. So ideally, what we would end up seeing is each of these versions get downloaded. It grabs the repo. We're probably going to use this name, right? So it's always Cassandra. So it's always going to be Cassandra.get. So it would be the repo. So one, it would clone, put it in Apache directory. Then it would switch to trunk and do the build. And then it would grab the artifact here. Okay, that's fine. Just got a branch. Sure. And what? Okay, so this is going to grab a bunch of tar GZs from here. This is going to create a bunch of tar GZs. The other thing is that this is kind of stupid here. This doesn't make sense because I don't want people to have to edit this. Maybe it doesn't matter. I might be nitpicking this, but I think that you probably want to do Cassandra versions custom.yaml, and I'll exclude that. And if it's there, then it will merge these files together, the Cassandra versions and this guy. It's probably the way to go. All righty. Well, it's been a little over 2 hours. I'm going to take a break. I'm going to get some food. I'm going to get some water. Thank you for joining me in my session here. I hope it was useful. And I'm going to keep working on this afterwards. And hopefully I can get this to a point where that disk stuff that I mentioned before, I definitely want to have in here. because once the disk stuff is working and I get a few other little minor issues fixed. So is this working? Oh, there it is. Oh, you know what? I'm not done. I lied. Let's let's just see what happens here. This is the problem with being slightly obsessed with this. Awesome. Bin easy cast lab up. So this is how I would work. Like, I'm going to try and get this. I'm going to do this as fast as possible. So I said a thing in 2 minutes. So let's see. So this was like what, 10 seconds so far. My clock says 1:17 right now. Okay, go ahead. You can edit patch.yaml. Nice. Waiting for SSH to come up. Is it going to work? Oh, fail. Timeout. Wah, wah, wah. Okay, at least I know now that this has got an SSH exception. So what I'm going to do is I'm just going to go ahead and like wrap this. And this is actually not even important. This doesn't matter. I don't care about that. And let's just go with an older version. Let's say we wanted to use 3.0. Okay, Pat, it's uploaded. So this is cool. So this is uploaded. The patch worked correctly, and we're able to get here. Now we see. Now we can do bin easy. Oh wait, let's just do the disk thing real quick. And while I'm at it, I'll just grab the. I'll just grab it. So I will actually have this. So this is on XVDB. So sudo make file system div xvdb. So this is going to be different. Like, it's going to be different depending on what instance type you launch. Like, there might actually be multiple drives, but for me right now, I'm taking the easy way out. Okay, so this was not on A, this was on B, right? And then we'll do sudo mount Cassandra. So the reason why this is cool, the reason why I actually really, really like this approach is if I just drop, let's suppose I just drop this in, right? I can also say like, here's some other ideas, right? Different instances, and later on, I could do different cloud providers. I don't really know. If like someone is interested in like Azure or GCP, like, you know, I know how I would do it. It's not a priority for me, but if it's a priority for someone else, that could be an interesting project that we could work on together. Like if your company, you know, is using Azure, I'm not against any cloud provider. It doesn't matter to me. Anything that Terraform supports, actually, anything that Terraform supports, I'm more than happy to do. So this Packer thing, like, there's not anything in here. There's very, very little in here that's actually Amazon specific. So I could probably refactor this a little bit to at least for the AMI. That'd be fine. Anyway, so that's done. I mean, I could actually just run this. So the other option I have is to just run this in here. No, not in here. In up. When up actually runs here, like I could just do it here. And it's fine. The only problem is if I do it here, then it's not as flexible. Like I definitely want the ability to test all those different disk configurations. I want to be able to test JBOD. I want to be able to test a RAID. I want to be able to test the LVM thing that I was talking about earlier. So we're gonna stick with that. I'm not gonna take the easy way out. And also like, whoops. So we also want to do read ahead. This is super important. And the thing that's really interesting about this is that the read ahead actually might have a benefit um, on EBS, because if you look at the documentation, EBS says that they measure IOPS as 16 kilobyte reads. And the reason why that matters is because if you are going to read subsequent pages, let's suppose you have 4K disk pages and you're going to read all of them. If you do 4 reads, separate reads, that might count as, I think that's going to count as 4 IOPS. And if you do read ahead of 16, then you're essentially kind of rounding up your IO to the minimum amount that they count as a single operation. So if 4K reads counts as 4 times if a 4K read is essentially counting as the same as a 16K read from their perspective, then it may make sense to actually do it. I normally tell people to minimize read ahead, but in this case, 16K might make sense. Anyway, we're just going to do that. So now that this is here, say, what did it tell me to do next? Use version. Right? I forgot if I already used 3.0. Whatever. Cool. Uploading. Okay. Patching. In. I think I'm ready to just go ahead and start. Cool. So now I go here. Oh, that was, I know what I missed. Okay. Disk setup. Go away, AI. And then okay. Mm. All right. So if I had done that correctly and then run start, basically what I'm trying to figure out is like, what do I actually need here? So I think that if I just drop this file in the directory, and then I'll do that on the init call. So when the thing starts up, it drops this file in. You can go ahead and make changes. You can do multiple drives. You can do JBOD, anything you want. And then and change how you're going to mount this. So that's straightforward, I think. Then, and as long as this is set up correctly, then I don't know. I think this might actually work. I just enjoy this. I don't know. I get a kick out of this. Okay, so T0. Hey, look at that. All right, cool. Okay, so this stuff works. It looks like startup complete. That's awesome. I need to. Oh, no, that's not going to work. Okay, so this is going to have to also set the. So it's going to have to write a CQL SH alias because this whole thing is kind of dumb. Like I hate having to do this. This is crazy. But yeah, okay. So this is. Oh, hello. What's up? It's a Stack Exchange site. Right. Multiple drives. Fancy pop-up. Lower third. Yeah, fancy pop-up indeed. Thank you for noticing. Look, I'm not experienced in this, so I still think that'd be fun. I think the pop-ups are fun. So what I'm going to do is drop a. I'm just gonna. You know what? Let's just go ahead here and. Does YouTube limit your bitrate? I have no idea. The answer to your question is I have no clue. I have no clue. I did actually pick up a. I don't know if the. I haven't looked at the quality, but I know that to do 1080p, they advise having a wired connection. So I'm waiting. The text is just blurry. Well, I'll try next time. The problem is that I'm on a 4K monitor, and well, it's actually not 4K. It's an ultra wide, and so it's whatever. So I've been trying to make the font bigger. I should probably just set up like a iTerm profile that automatically has bigger profiles, and I'm gonna plug in because I might be only streaming at 720 right now, so maybe it'll be a little bit better at 1080. Appreciate the feedback. I'll see what I can do. I'm still learning, Still learning. This years from now, we're gonna look back and laugh at this. my terrible decisions. I'll get that figured out. Okay. So cool. I am done now. This has been a 2.5-hour session for me. I would love to do this again if I actually really like this. So I am going to do this again. I'll probably do this again next week. And I'm also interested in having folks on to chat about what they do. So if you've got kind of a community, a use case that you want to talk about, love to have you on and talk about this. And yeah. All right, we'll get this fixed. Promise I'll get this fixed. I will do better. I'm always trying to do better. So in the near future for me, after I eat something, which would be wonderful, I'm going to get this. I'm going to get this thing figured out, and hopefully by next time I can actually demo a 2-minute provision with any version with a full cluster. And I think that'll be pretty cool. Yeah. Exactly. Thank you. Appreciate it. Thank you for not holding me, too responsible for for my ignorance. Um, we'll get better. My goal is to get better. Uh, but next time, like I said, next time I'm going to have this whole thing going. I want to have the ability to provision. I want to show you a 6 node, or maybe three or 6 node provisioning with a stress instance. My goal is to have the whole thing running, and I'll even, I don't know if I can put like a cool timer on here that we can, that I can have counting down for the drama. But if I can do something for dramatic effect, I will, and then we'll have a little fun with it, and hopefully I can show you how to use this to fire up a cluster and start testing stuff, because this what I've been working on today is only the lab tool. The stress side of things, uh, I absolutely love the stress tooling. I was so happy when I built it at the last pickle. We used it for everything. It's literally used to test like some of the most. It's used to test infrastructure that you're probably using already, and it's one of the most critical pieces of software for several companies that run Cassandra. So, yeah, hopefully I want to get into that. I want to show you a little bit about EasyCAS stress. But you don't need to use them both. So if you already have your environment, you can use EasyCAS stress. If you want to set up a lab environment, you can use this, and you can use NoSQL Bench. I don't care. The whole thing is really kind of designed as loosely coupled parts because that's just good. I really don't like systems that have a lot of tight coupling. So mix and match components. And yeah, even if someone wants to contribute, like installing NoSQL Bench on here, we do that too. I'm fine with that. So actually, I should probably reach out to Jonathan Shook and see if he's interested, because he's a really smart dude, and I bet he would be interested in seeing that in here. So I'm going to reach out to him. Which part? Which part sounds interesting? Is it the whole thing? I think it is. To me, this is a lot of fun. So we'll start benchmarking, and then after that, so I would love to get some feedback here, because is it useful to see version comparisons, Cassandra 3 to Cassandra 4? Is it interesting to see like what happens when we test streaming between versions, or I go ahead and do performance tuning? Like if I set up a 3-node cluster or a 6-node cluster or something, and I do an hour of performance tuning on that, is that interesting? Is that useful? Please let me know. I would love the stress testing. Yeah, I really enjoy it. And the thing is that I'm doing this stuff anyway. Like I'm actually doing this. So if me broadcasting this is going to help people, I'm happy to broadcast it. It's just I just would love to get the feedback. So reach out to me on Slack, on the ASF Slack, Rusty Razorblade. If you're interested in kind of getting involved with some of these projects, let me know. If you're interested in saving money, this is the big one. This is a consulting company as well. So I have consulting and I have training. I can come in and literally change a team in not a lot of time. I can say from my experience that I have helped some teams go from like here to here, and the impact can be enormous. So I love to help people out, and if you want some help there, just let me know. And I'm happy to teach how stuff works, and tune clusters and help you save a little bit of money in the process. I guarantee that the amount of money that I can save you will be significantly less than I will charge you. So it's actually a net win. So if you want to spend a little bit less on your Cassandra cluster and your bill, if I can save you a couple $100,000, you'll probably be pretty happy. So definitely give me, hit me up. And if not, I can see you in the stream here, and I'm going to be demoing this stuff. I'm going to be doing benchmarking, as I mentioned. So, all right, I'm done. Enough rambling. Thanks a lot. I will see you around in the community.